Hello everyone. Today we're going to be talking about the copy constructor. Now in C++, the copy constructor is what allows you to be able to pass things by value instead of by reference. Now what I have downloaded here is your array object that you've been working on in class. This is an editor called Genie or Geanie, however you want to pronounce it. And basically it's just a text editor here where I'll be editing the code, and a terminal down here where I'm just going to be manually compiling. Don't let that throw you off. You can do this in any kind of IDE. So moving on. So here, this is the functionality that we're going to implement today. This is the copy constructor where we have a new object, array 2, and we pass in array 1, and the behavior that we want is that after this constructor is called, we want array 2 to have the same values as array 1. So I'm going to go ahead and just compile it. Oh, well, a little bit of a preview. Okay, so now I'm going to run it, and you'll see that the behavior that we have implemented is working. So let me go ahead and dive into the code and show you what's going on. Okay, so in the header file, this is what our copy constructor is going to look like. Now, notice that we are passing this second array by reference. Now, if you think about it, it makes a lot of sense. Without the copy constructor, you can't pass something by value, and right now you're implementing the copy constructor, so it makes sense that you wouldn't be able to send it by value because you need the copy constructor, and so on and so forth, and becomes this infinite loop of, needing. All right, so pass it by reference. Now, there's one other function in here that I've added, and I'll show you why in a minute, and that's just this getter function that's just going to return the size. So I'll show it to you here. So here, it just returns size, the member variable size. And I'll show you why I need that in a minute. Okay, so we're passing this object by reference. And if you recall, in our header, these member variables are private. So if they were public, then I would be able to access, I want to set the size of my current object that's doing the calling to my original dot size. So you may think that you would just come in and say orig.size, and you can access it that way. Now, if you make your variables public, which is a bad idea, but if you did, then you would be able to do this. But we're not going to do that. Instead, for data security reasons and good programming practice, we are going to implement this getter. So this getter is going to get our size from our original, and it's going to set it to our size of our calling object. So we are going to initialize our data array with our new size. And now we're going to loop through, and we're going to set each of our elements of our data array equal to original.getI. And if you remember that function, I'll show it to you. It takes in an index and it returns the value at the index. So pretty simple. So we're going to implement it this way. Now again, if you had things as public, you would be able to do this, but it is a bad practice. So you could access it directly, but that's a bad practice. So do it this way. All right, notice that it is a deep copy instead of a shallow copy. So shallow copy with pointers arrays may be very tempting, but in this case it is also very bad practice. If you think about it, you have a bunch of objects that all their data is pointing to the same place. If that place gets modified, then you corrupt all of your objects. So it's really a bad practice and should be avoided. Thus, deep copy and not shallow. Now, one thing that you may have noticed if you are following along with your array object, now I pulled this straight down from from your Dropbox, and before, and I deleted it, and I'll tell you why, and we'll discuss it in the next video. So before there was a const here. And that is a really great practice, and it's something that you should implement. Anything that you pass by reference that you don't intend to modify, you should always put a constant modifier in front of it. And that keeps the data safe. Now, well, I guess I can give you a little bit of a preview here. So if I go in and I add this const back, now I'm going to go ahead and I'm going to run my code, or I'm going to compile my code again. I'm going to get an error. And this error is what we're going to discuss in the next video. We're going to talk about constant functions and just constant variables and the concept of const in general. So stay tuned. Thanks.